Dear students, now we are going to discuss about the polar plot. So last topic we have discussed about Bode plot. The similar way here also we are discussing about polar plot. The other name of polar plot is Nyquist plot. So here the magnitudes are represented by normal values only. So now the polar form of g of j omega and h of j omega is modulus of g of j omega in h of j omega and phase of j of j omega into h of j omega. So the polar plot is a plot which can be drawn between the magnitude and phase angle of g of j omega and h of j omega by varying omega from 0 to infinity. So here the polar graph is shown in the following figure. See here. So this is the polar graph. See, this is a polar graph. So we are plotting the phase values so surrounding this graph. So now the graph sheet consists of concentric circles and radial lines. So the concentric circle and the radial lines represent the magnitude and phase angles respectively. So these angles are represented by positive values in the anti-clockwise direction. So these points are very important. Note down. These angles are represented by positive values in the anti-clockwise direction. Similarly, we can represent the angles with negative values in clockwise direction. So for example, the angle 270 degree in this direction is equal to angle minus 90 degree in the clockwise direction. That we can easily visible here. See here. So what we are informed that 270 degree in anti-clockwise direction is equal to the minus 90 degree in the clockwise direction. So you can visible here. See, this is 270 degree in anti-clockwise direction is equal to, see here, minus 90 degree. So now this is the polar graph. So what are the rules for drawing polar plots? So follow these rules for plotting the polar plots. First thing, substitute the s is equal to j omega in the open loop transfer function. So write the expression for magnitude and phase of g of j omega and h of j omega. Find the starting magnitude and phase of g of j omega, h of j omega by substituting omega value is equal to 0. So the polar plot start with this magnitude and the phase angle. So find the ending magnitude and the phase of g of j omega and h of j omega by substituting omega is equal to infinity. So the polar plots end with this magnitude and the phase angle. Check whether the polar plot intersects the real axis by making the imaginary term of g of j omega and h of j omega equal to 0 and find the values of omega. So point is very important. Check whether the polar plot intersects the real axis by making the imaginary term of g of j omega, h of j omega equal to 0 and find the values of omega. The next thing is check whether the polar plot intersects the imaginary axis by making real term of g of j omega, h of j omega equal to 0 and find the values of 0. The next thing is for drawing polar plot more clearly, find the magnitude and phase of g of j omega, h of j omega by considering the other values of omega. So these are the very important rules of plotting the polar plots. We have to follow these procedures. Now we are taking the first order system. See here the g of j omega is equal to 1 divided by 1 plus tau s. So here the tau is the time constant. So instead of tau, instead of s for the frequency system, you have to substitute s is equal to j omega. Now you need to take multiply both numerator and denominator by conjugate of 1 minus j omega tau. So after taking that your function will be become, see, like that. G of j omega is equal to 1 divided by 1 plus tau square omega square plus j minus tau omega divided by 1 plus tau square omega square. So after taking that, so based on the formula a plus jb, how to take the magnitude root of a square plus b square. So based on that we are calculating the magnitude, and again the formula is phase value minus tan inverse of b by a. Based on that, from the equation g of j omega, see this function we are taking as like that a plus JB. So from that here you are taking A square plus B square. Similarly here also you are taking tan inverse of B by A. So now after that we need to start to point the plot. So first we need to start off the plot where omega is equal to 0. We have substitute that the modulus of value magnitude value will be 1 and phase value will be 0. And they had to substitute infinitive. Then now the magnitude value is 0 and the base value is minus 90 degree. Now you need to find where the plot crosses the real axis, and the next thing you have to find where the plot crosses the imaginary axis. So finally where it coincides with the point, see here the point 3 coincides with the point 1 and 2 and point 4 coincides with the point 2. So that thing we are plotted here. So this is the sketching the polar plot of first order system. Check here the point 3 is coincide with the point 1 and 2 and point 4 is coincide with the point 2. We need more values for evaluating the different frequencies. So here taking omega value is 1 by tau. So based on that we are plotting the polar plot. Thank you.